GIMS is a project founded by European Community. The name states for Geodetic Integrated Monitoring System. Is a system that is going to integrate different technologies that provides different aspects on the monitoring of a structure or a land. In these slides you can see a map that is not here only for filling the white space, but it's a map that represents the high landslides hazards that we have in Europe. As you can see, we have a lot of really light areas, and those light areas are the areas that are more subject to landslides. You can see that there are a lot of them in Italy, but even a lot more in Slovenia. So we have this problem that it's spread all over the world. There are hundreds of landslides every year happening all over the world. We have buildings, railways, and a lot of structure that have been built on top of landslides. And we need to monitor them most of the time to prevent injuries or even deaths. The project, as I told you before, has been founded as an H2020 program under the supervision of GSA, that is the entity that manages the Galileo satellite system, that is basically a global positioning system. I'm from a company called GRED, located in Italy, born in 2012, and we are the main entity of this project. We are making the analysis of the GNSS data and the management of the project. There are also other partners. One is Safirion, that is the producer of the hardware that we are going to use for monitoring with GNSS data. Then there is Geonumerics, located in, well, Safirion is in Switzerland, Geonumerics from Catalonia, that is going to analyze the data from IMU units. CTTC developed an active corner reflector used for enhancing the SAR processing from Copernicus data that are freely available thanks to ESA. Then we have CommonNext that provides part of the project management together with us, and also built the business development of the project. And the GeoZS that is the geological, provides the geological interpretation of the data that we are going to obtain, and that it's also an example of the final user for us. The most important factor of our project are the integration of different systems, all in, with a unique idea of being low cost. So we are going to use a low cost GNSS unit hardware and also low cost corner reflector that have been designed to be with a cost that for a unit will be less than 4,000 euros, for example. The system is have been developed to be an end-to-end service, so we will provide it as a service to the clients, and is going to use Galileo GNSS, Global Navigation Satellite System. Is going to use IMU, that are accelerometer basically, and InSAR data. Those three technologies are one complementary to the other. We have the GNSS that can provide long-term deformation, constantly monitoring every day, every hour, the movements of some points. So we have a continuous data. Then we have accelerometer that can provide fast alarms, because they can sense that there have been a sudden movement in basically no time. And then we have SAR images. The SAR deformation images are provided every 6 days, typically, on the passage of the Copernicus SAR satellite. And they can integrate the high temporal resolution of accelerometer and GNSS with a high spatial resolution. So we will have all the kinds of monitoring for the deformation of a certain site. The integration of Galileo and also other satellite systems can be very useful, especially in a condition of bad sky visibility. Here we have a penstock that we are monitoring in Italy, and as you can see, the problem of the penstocks is that they are typically surrounded by trees, so the visibility of the sky is really limited. And adding more satellites on our computation, we can improve and remove all the false alarms and improve the solution up to 80%. The project is now, well, it's a project that will last for 3 years, and we are more or less in the middle of the project. So we already started the development and we finished all the prototypes of our hardware, and we are going to install the instruments on one of 2 of the sites that we will going to monitor here in Slovenia in the next months. This is an example of well, the hardware for the GNSS. This is the box that have been built together with a battery and the sonar panel, so all the sensor will be independent. This is the data set from these preliminary units. These are some of the instruments that we are going to use as IMU, and this is an inclinometer that we will integrate to the solution. And then the data of the accelerometer, and this is the active corner reflector. Basically, it will receive the signal from the SAR satellites and return an enhanced version of this signal to be able to see it clearly on a map. This is very useful in area where you have a lot of vegetation, for example, where you don't have anything that reflects the SAR signal, and you can have a better visibility of the deformation of the point and a better adjustment of the map, of the SAR map. And now I will leave the stage to Mateja that will present the installation sites.
Thanks, Andrea. Andrea already mentioned that Slovenia has some problems with landslides, and I will, for the start, I will present a little bit introduction why our territory is a little bit high exposed to landslides occurrences. So the main reason for landslide occurrences in Slovenia are lying in the complex geological structure and tectonical structure. Slovenia, our territory, is lying on the Adriatic plate, and this plate is squeezed between the African plate to the south and Eurasian plate to the north. And as consequently, numerous faults and thrusts affect our countries and cause unfavorable geological conditions and diverse morphology. This landslide susceptibility map provided by the Kovac and Ribicic shows that almost 1/3 of our territory is highly prone to landslides, and more than 10,000 landslides have been recorded in the past 25 years, and among of them are also, let's say, more than 10 landslides that are categorized into big landslide with a volume exceed 1 million cubic meters. I here just show some of the big landslides appear in Slovenia that cause a great damage to infrastructure and also to buildings, and even cause, unfortunately, human casualties. So why we selected for the first pilot area Vipava Valley? We are going now to the southeastern part of our country, Slovenia. Here is the Vipava Valley. Well, here continues a very important highway or motorway connects Slovenia and Italy. The second reason is also that it's a good 3G connectivity. As Andrea mentioned, this is one mandatory for deployment of GIMS units, and as well also a good slope orientation due to the SAR satellite, And of course, also we expect ground motions related to the landslides. Of course, I need to tell also that geological structure here in this part is very complex. And due to these complex geological structures, we have carbonate rocks that are overtrusted to the very soft flysch rocks. And here, these scree deposits recently have breaking down and caused steep fans of carbonate scree deposits. So, and that's mean that a large part of precipitation can easily penetrate to this very deformed and structurally deformation classic rocks, and additionally weather the very soft rocks. And as a consequence, we have many superficial slides along this highway or motorway, starting from the Razdrto-Vipava town a little bit longer. So, yes, we decided already to select 3 locations where the GIMS units will be installed in the, along this motorway. In these 3 locations, we mostly focus, we are looking for the bridges, for the construction of, let's say, for the bridges, for the concrete foundations, and also for the retaining wall, and also other possible locations that could be useful for the GIMS deployment in the, along this motorway. Of course, inside of the, let's say, safety fence of the this motorway. So here are just a few examples of the bridges where we are going to install, let's say, the GIMS units and try to capture ground motions in relation with the landslides. So as I mentioned, Andrea, let's say we are going to deploy GIMS units at the end of next month. And after this installation, we will start with validation processes, and our results, GIMS results, will be comparable with the pre-existing data from the boreholes and geodetics nets from the company that continuously monitoring already this motorway. So we are expecting the first results at the end of summer.
Obviously, it's important to notice that the mandatory low-cost objective of the goal of the project is due to the fact that there are many landslides all over Slovenia and all over Europe, all over the world. And it's very important to keep the cost very low in such a way to have more points to be monitored and more sites to be monitored with the same amount of money. Because typically just a unit of a GNSS receiver can cost, a geodetic receiver can cost up to 20,000 euros. While this kind of units, together with the corner reflector, will cost something like 4,000 euros. So a lot less and a lot more possibilities.
That's it?
Yeah, that's it.
Thank you, Andrea. Thank you, Mateja.
How do you estimate the situation on this particular motorway? What can we expect in the...
So in the sense of motion, displacement rates.
Yeah.
Well, we are geologists and we do very detailed field investigation before we decided for those 3 locations. So let's say there are new cracks on the road behind of this motorway, and also a new open cracks on the let's say above the on the field above this motorway, as well some subsidence of the motorway, concrete on the motorway, that shown on the, let's say that we could expect motions in order of 1 to 5, let's say, or 1 to 4 or 3 centimeters per year. And of course, we are collaborate here with our owner of this motorway. They will provide to us the data for the validation. And they also know for this project, they are willing this project, and they would like to, they are interested, of course, for the results, and maybe these GIMS units will be comparable and additional monitoring system after the validation phase. So, okay, you're welcome.